Everyone, welcome to example 3. We're going to graph f of x equals 2x over x plus 1 and state the domain and range. So let's go ahead and get started. Let's look for our big 4 here. So let's look for the x-intercept. Okay, the x-intercept here is going to be where you set the numerator equal to 0, so 2x equals 0, which means x equals 0. So you're going to have an x and y-intercept that are both going to be 0, okay? 0, 0. So there's the origin, and if I go ahead and try to do the y-intercept, you plug 0 in for x, so you're going to get 0 over 1, which is 0. So the x and y-intercept are both 0, 0 here, okay? The vertical asymptote, okay, what can't x be? That means set your denominator equal to, set your denominator equal to 0. Okay, so I'm going to go ahead and do that. So x plus 1 gets set equal to 0. So x equals negative 1. There is my vertical asymptote. I could do the domain now if I wanted to. So x is negative 1. There's that. Now I have to find my horizontal asymptote. The horizontal asymptote is when you look at the powers. Both of these are first degree. So y is going to equal, you divide the leading coefficients, which is 2 over 1, which is 2. So there is our horizontal asymptote at 2. So now that I have those two, I can do my domain and range. I have this nice point 0 here. I could plug in 1. So after you get the big 4, it's table time. Okay, so I'm going to go ahead and make a table. I can pick anything I want except for negative 1. I can't use negative 1. I'm going to pick 1 here because I get 2 times 1 over 1 plus 1. So 2 over 2, which is 1. So my next point is 1, 1. Okay, so now I can go ahead and sketch this part by following each asymptote. So I got the first part of my graph. Okay. Now I'm going to go ahead and pick another point. So I need something over here. I'm going to pick negative 2. And watch why I pick negative 2. So I get 2 times negative 2 over negative 2 plus 1, which is negative 4 over negative 1, which is 4. So I plot negative 2, 4. So negative 2, 4. Okay, I could also do one more if I plugged in negative 3. And I'm picking these x values because I get a fraction that gives me either a whole number or an integer, and I like that. So if I plug negative 3, I get 2 times negative 3, which is negative 6, over negative 3 plus 1 is negative 2, and so that's just 3. So I plot negative 3, 3, and there we go, a little more accuracy with my graph. And there we go, there's our rational function. Okay, you got to state the domain and the range. The domain, I have to take care of everything before negative 1 and everything after negative 1. So before negative 1, it's negative infinity to negative 1 in union with everything after 1 to infinity. And my range, okay, the range of this function is from negative infinity to 2, and then from 2 to infinity. So negative infinity to positive 2 in union with 2 to infinity. Okay, so there's that example.